Hi, my name is Ben from Vectrix, and in this video I would like to explain how you can use the Voyager Multi-Modal 3 embeddings model, which is now the state-of-the-art model concerning embeddings, how you can use that to retrieve both text and images that are embedded within the same space. Now let me first explain why this is so important. With a traditional embeddings model that just embeds texts, if you have a magazine that contains both pictures and text, you will only search, of course, for the text and you will disregard all the images. On the other hand, if you have a model that can just embed images, you will look for the images in the magazine, but you will not retrieve any text. If you have an embedding model that can retrieve both of them within the same space, this allows us to do very powerful things. For example, if you have a magazine and it contains pictures about a mountain and then some text that gives some more context about this mountain, you can retrieve both of them, making your retrieval pipelines a lot more accurate. Also, if you would just search for the images, you will not return the text that is also related to those images, so you will miss crucial information, and vice versa. If you would just look for the text, it might refer to some image that is not included in your search. So it really enhances your RAG functionality to embed both images and text within the same space. So this new Voyager model allows us to do this. It's a state-of-the-art model. I will link this blog post from Voyager AI in the description. But as you can see, I will scroll down a little bit. You can see that this model scores is the best scoring model concerning embeddings across the board, even is better than the newest models from Cohere and OpenAI. It's also good in just retrieving text or just retrieving images or tables and figures. But what's more important is that it's able to embed all these things within the same space. And I will actually show you first with a demo why this is so important. So for this demo, I've indexed this photography magazine and I embedded both text and images. So as you can see, it contains a lot of pictures. Let me show you some. And the text also refers to those pictures. So it's very important to actually understand this magazine and ask questions about it, to have a concept of both the text and the images. So let's say, okay, we have this page with a fox. Let us ask some questions about it. So if I open my LangGraph Studio here in the browser, you can see this is the flow. So first we do a multi-modal retrieval. So, and then we send the retrieved data to an LLM to answer the question. So basically what I will do is I will open this. I've already typed in the question, what does the magazine say about a fox? And it says the magazine does not provide any specific information about a fox. They primarily focus on landscape and nature photography. So it answered this because I only searched text. I only did a similarity search on text. So I didn't give the model any images. So you see that the answer is not really good. If I now enable the multi-modal embeddings, you will see that the answer is a lot better. So I will just rerun this. And it should be better. Okay, let's see what it says. The magazine features an image of a fox, specifically in the context of wildlife photography. It highlights the beauty of capturing nature and wildlife, such as the fox in outdoor settings. So there is no specific text of the fox, but it is shown prominently in the images. So you can see this is a lot more accurate, this answer. And if we go actually to our Langsmiths, I'll open the last run. So the last two questions we asked, we can actually see what was sent to the OpenAI model. In the first part, we just sent the text to the model and then it couldn't really respond. In the second try we just made, you can see that if we open here that you can see here that the image of this fox was actually sent along with the text next to it to the model. So the answer was a lot more accurate, improving our results. So as you can imagine, this is just a simple photography magazine, but you can use this for a lot of other flows, a lot of other data, even with tables that contain a lot of interesting information you might want to ask questions about. So let me show you how I made this. Okay, so now let's see how I've built this. It's actually pretty easy. You only need a few steps to do it. I've created this notebook with some explanation. I will add a link to it in the description so you can download it on GitHub. Also, all the other code is there from the LangGraph flow I showed before. So you can just download it, follow along, or use it as a base to start working on your own projects. So the first thing we need is a vector database. I use Weaviate because I'm used to it. I think it's a very good vector database, but you can use any vector store possible that allows you to use a similarity search. So basically what I do is I connect to a local Weaviate instance and then I create a new collection. As you can see, I don't select a vectorizer. Why? Because Weaviate doesn't have a built-in vectorizer for the Voyager Multi-Modal tree model. So we have to vectorize the data ourselves. So we have to send all the text and images to Voyager AI. We will retrieve it. We will retrieve the vector embeddings, and then we will insert them manually into Weaviate. So what I've just done is I just created this new collection for the demo. First step is extracting all the data from the PDF. So the PDF file I showed earlier, the magazine, I created a sample of this one here. And what I will do is I will use the unstructured Python library, which is an open source library that allows you to extract data from various kinds of files, Word documents, Excel files, whatever. I use a PDF file in this example. So basically what I do is I say I want to extract images, so I use these settings for it, and I want to extract tables, and I also want to extract the image payload. So what it will do is it will extract all this information and add it as an element, and then we will chunk it into logical sections. In our case, the logical sections will be titles. So basically by running this, we will group all the extracted elements into logical chunks, because of course if we want to embed something and we want to later retrieve it, we want to retrieve everything else that is correlated to this data. So most of the heavy lifting was done by unstructured. So we have our chunks, we have our data. We have to do some custom work here to make it work nicely. So basically what I do here is I iterate over all the chunks that were created by unstructured, and I will extract some of the metadata. So I will extract the file name, the page number, the text where the image was on, the language we detected, the file type. In this case, it will always be a PDF file when the PDF or file was last modified. So it can be interesting data if you want to filter on at a later stage. We'll also convert the base 64 decoded images to a fill image. So basically this is Python pillow package. So it's a standard Python image library. We do this because if we want to send data to Voyager AI, it needs to be in this fill format. So we just run this now. It should be very fast. It should only, takes 0.6 seconds. So if you see the result then, so it will return two lists, one with the actual objects we will send to Voyager AI to get the embeddings returned, and then we have another list with all the metadata correlated to those objects. So let us see. So the first thing, the first two chunks here. So it's a list of lists. So each list contains text and then some images that are correlated to this text. The second one is just text. Maybe another one can just be images. It can be both just one or just one type. So it can be a mix of everything. And then we have the metadata correlated to these embeddings. So as you can see, we have the file name, the page number, and all the information we discussed above. And we also have the actual image data as base 64 encoded strings. Why do we have that? Why do I put the image data in the metadata? Well, if we want to retrieve an image from our vectors, if we want to do a similarity search on our vector store at a later time, it will also retrieve not only the text, but actual images. And we can then pass that on to an LLM. And then the LLM can give us much better answers than if we were just returning the text. So as you can see, both the metadata and the objects should have the same size, otherwise we cannot embed them properly. So what we will do now is we use the Voyager AI package. We instantiate it. You need a Voyager AI API Voyage API key as an environment variable. Otherwise, it will not work, of course, as it is an external API. You cannot run the model locally. It's a commercial model, so it's not an open source one. So we send it. We say, okay, we want to use a multi-modal version of Voyage 3. Don't truncate it, and just pass us the results. So it will take us a few seconds. I don't think it will take a long time, since it's just a small sample. Okay, so all the data is vectorized. We will show the results. So as you can see, we also have a list of lists. So this data here is now converted to embedding objects, which we can insert into our vector store, and that's what we will do here. So in here we will add all this data in one batch, in one go, into Weaviate. So in the property variable, we will add the metadata, and we will also pass the actual vectors, which are these ones, into the vector store. Yeah, I thought you just now fetch the objects. So as you can see, they're added, but it will make more sense what we've just done if I actually do a search inside of Weaviate, which we will do now. So maybe a little bit of an explanation. So we have our question. So what does the magazine say about a waterfall? Then we have to vectorize our question, because I said earlier that Weaviate doesn't have a vectorizer for Voyage Multi-Modal 3, so we have to vectorize the question ourselves. So this is what we do, and then we we actually do a near vector search. We say, this is the vector, can you return all vectors that are closely related to it, and it will return that, and then we will display the results, and we will also display the images that it will return. So what does the magazine say about a waterfall? If I run this query, it will return us some texts. Yeah, okay, we have some spaces here, so maybe we need to do some more data cleaning, but this gives you the idea, right? So it also returns images of waterfalls, and also very important, it returns the text that is correlated to those images. So as you can see, I asked a question about a waterfall. It will perform a similarity search on this picture, but it will also return the text, and this text doesn't specifically mention the word waterfall. So it is very interesting. This text refers to the waterfall, but it doesn't mention it. So by having these both embedded in the same space, you retrieve all relevant information. This is also a picture of a waterfall. I hope this was interesting. I also written a blog post about this with some more information, some more details. Maybe I can show it really quickly. This one here. So where I go, actually everything I explained here, I have the examples in this blog post also. I will link it also in the description. Let me know if you have any questions in the comments or on my, I will link also in the video how to contact me. I hope this was interesting.